Welcome to the video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about waveform distortion and distortionless line. So let's see the image in this diagram. So what it indicates. So here some distorted signal is present. So we are not going to get the original signal or image from this picture. So what is distortion? A signal transmitted over the lines are normally complex and consist of many frequency components. So for ideal transmission, waveform at the receiving end must be same as the original input. So it means it requires all the frequencies have the same attenuation and the same delay. So caused by finite phase velocity or velocity of propagation. So when the conditions are not satisfied, distortion exists. So we are not going to get the original input signal. So distortions occurring in the transmission line are called as waveform distortion or line distortion. So there are two types of waveform distortion. One is frequency distortion, second one is phase or delay distortion. First type, frequency distortion. When a signal having many frequency components are transmitted along the line, all the frequencies will not have equal attenuation. So for example, voice signal is a complex waveform consisting of many frequencies. So in the receiving end, the waveform will not be identical with the input waveform at the sending end because each frequency is having different attenuation. So this is called as the frequency distortion. So methods to avoid the frequency distortion. When the attenuation constant is not a function of frequency, frequency distortion does not exist on transmission lines. So in order to reduce the frequency distortion, attenuation constant should be made independent of the frequency and equalizers can be used to minimize the frequency distortion. Equalizers are the networks whose frequency and phase characteristics are adjusted to be inverse to those of the lines, result in the uniform frequency response over the entire band. Hence the attenuation is equal for all frequencies. Phase distortion. When a signal having many frequency components are transmitted along the line, all the frequencies will not have same time of transmission. Some frequencies being delayed more than the other. So the received waveform will not be identical with the input waveform at the sending end because some frequency components will be delayed more than the other frequencies. So this type of distortion is called as the phase or delay distortion. So methods to avoid the delay distortion. Phase constants would be made dependent on the frequency. The velocity of propagation is independent of frequency. And delay distortion is relatively minor importance to voice and music transmission because of the characteristics of ear. It can be very serious in circuits intended for picture transmission and applications of the coaxial cable. In such cable, the internal inductance is low at high frequencies because of skin effect. The resistance small because of the large conductors. The velocity of propagation is raised and made more nearly equal for all the frequencies. And condition for a distortionless line. A transmission line is said to be distortionless when attenuation constant alpha is frequency independent and the phase shift is linearly dependent on the frequency. Condition for the line to be distortionless is R by L equal to G by C. Assessment questions. Transmission line is distortionless if R by L equal to G by C. The answer is B. The distortionless line is one in which the attenuation constant and phase constant are independent of frequency. So the answer is false because one is dependent and another one is independent. Which two parameters given below are 0 in lossless line? So the answer is conductance and attenuation, C. So these are the references. Thank you for listening.